Okay, where we left off, I was talking about the measurements of market power, and we talked about the concentration ratio. And I forgot to mention about some of the problems with the concentration ratio. There's two main problems with the concentration ratio. One, it doesn't tell you how many firms are in the industry. It just tells you something about the four largest firms. So that's a problem. Another problem is it doesn't take into account market power at the local level because there may be some firms that are not competing nationally, but they have substantial market power locally. I mean, a very good example would be newspapers. Um, think about the San Francisco Chronicle. Nationally, its market share is very, very small compared to, let's say, the New York Times, Washington Post, or the Wall Street Journal. But in the San Francisco Bay Area, it has significant market power because it has a significant market share in that uh, local region. So those are two issues with it. And so there is another measurement that's a little more sophisticated than the concentration ratio, and that's called the HHI, the Herfindahl-Hirschman Index. And unlike the concentration ratio, the HHI looks at all market shares, not just for the four largest firms. And the way it works is it takes the market share, then squares it, and then adds it up. And this is what this equation basically says. This says take the share of a firm, square it, and then sum all firms and number of firms. One little trick is market share is a percentage. Let's say if you have a 20% market share, that's 0.2, right? Well, what we do with the HHI is we take that 20% and we turn it into a whole number. So 20% turns into 20, 15% turns into 15, that sort of thing. So let me show you an example. Let's say there are uh, four firms, each with, now again, I apologize for using four firms because this is easy to confuse with concentration ratio. Remember, with HHI, you do this for all firms, not just the four largest. So 30%, 30%, 20%, 20%. We take these and turn them into whole numbers, 30, 30, 20, 20, and we square each one. Now, the reason why we're squaring it is the HHI tries to give more weight to those firms with larger market share. And you get a score of 2,600. Now, what does this number mean? Is 2,600 uh, um, uh, closer to monopoly or closer to perfect competition? Well, let's use the Department of Justice to tell us how to interpret these numbers. The reason why I'm going to the Department of Justice is because if you want to merge with your rival, you have to get permission from the government to do so, and it's the Department of Justice that is in charge of this. And they say any number, actually this data is a little bit outdated. Um, it used to be 1,000 to 1,800. Now it's 1,000 to 2,500 is considered to be moderately concentrated. So any number above 2,500 is considered to be highly concentrated. And transactions, this is mergers. That's what they mean by transactions. So mergers that increase HHI by more than 100 points or a score of 1,800 would raise antitrust concerns. Now, let me again update this. The Department of Justice has changed this to 200 points. I'm sorry, I should have updated these slides. And again, this should be 2,500. So this should read mergers that increase HHI by more than 200 points or a score of over 2,500 presumably raise antitrust concerns. Now, let's talk about a specific model of oligopoly, and this is called the uh, Sweezy um, or kink demand curve. And in this case, we're going to make some assumptions. If a firm is considering a change in output or selling price, there are many possible reactions that can happen. And there are two possible options. One, you could assume no change to rivals' output. In other words, your rival is not going to respond to your moves, or they will respond to your moves. Now, let's look at that assumption via the Sweezy model or the Kink demand curve model. In this case, we have a few firms in the market serving many customers, and they're producing differentiated products, and there are significant barriers to get into this industry. And now, this is critical, each firm believes that rivals will match price reductions, but will not match price increases. So if a firm raises price, rivals say, go ahead, raise price, because when you raise price, I'm going to steal your customers because you're making your product less attractive relative to mine. But if your rivals lower price, they're going to match those price cuts because they want to protect their market share. Now, let's look at this. Now, how do we show this? Well, one problem we have is if we look at a simple demand curve like this demand curve is supposed to hold everything constant except for price. So when you change price, you move up and down this demand curve. But if rivals match price reductions, but not price increases, that's a problem because rivals are doing two different things. With a oligopoly or with a demand curve, rivals' reaction have to be the same, going up in price or going down in price in order to hold everything constant. So how do we take this into account when rivals will do one thing when we raise price and do another thing when we lower price? The way we do that is we're going to introduce two demand curves and combine them. One demand curve, as you see here, this demand curve will represent a demand curve where rivals will hold its price constant, or in other words, they will not copy our price changes. Now notice this demand curve is relatively flat because if we change price and our rivals do not, our customers are going to be sensitive to our price changes because we're going to be significantly different than our rivals. Another demand curve is when our rivals will copy our price changes. When we raise price, they raise price. When we lower price, they lower price. And that means our customers are not going to be as sensitive. So this curve is relatively inelastic compared to the other curve. That's why it's relatively steep. So flat demand curve with a flat marginal revenue curve, steep demand curve with a steep marginal revenue curve. But only parts of each curve are going to be relevant. So let's start where the two curves intersect. And what would happen if we raised price? If we raise price, our rivals will not match our price increase. So we're going to be moving along the flat demand curve, this part. When we lower price, we're going to be moving along the steep demand curve because our rivals will match our price change. So this is why I highlighted this part and this part. And this is the kink demand curve. Now, because this demand curve is relevant, that means this marginal revenue curve is relevant. Because this demand curve is relevant here, this marginal revenue curve is relevant. So let me highlight that for you. Notice how this marginal revenue curve goes with this demand curve, and this marginal revenue curve goes with this demand curve. This is the Sweezy marginal revenue curve. Now, both of these curves, the kink demand curve and the marginal revenue curve, have implications in terms of outcomes for this industry. In other words, these are ways to demonstrate price and output are more stable in oligopoly than in monopoly or in perfect competition. How do we demonstrate that? Well, one way is, let me bring it back here. Look at the kink demand curve. When we raise price, the question is, do we move along this curve or this curve? And I've already highlighted for you, we move along the flat curve. So raise price, you move along the relatively elastic curve. So remember from price elasticity, I'm going to draw something for you here. So let's do the rubber band theory. So when we got price, we got total revenue. So when we raise price, we move along the flat demand curve, and that's going to cause a significant drop in sales, and that's going to lower our total revenue. And this is the rubber band, right? And it stretches. So this is relatively price elastic. Now that means firms don't like that. They don't like it when their revenue drops. So what would happen if they lower price then? Let me erase this. Let's try this again. Now, if they lower price, they move along the um, steep demand curve here, right? And they lower price, but everybody else lowers prices. So they don't get a substantial increase in demand as a result of lowering price because everybody's cutting price. So they're going to see revenues fall. And notice how the arrows move in the same direction. This is price inelastic. So let's recap. You raise price, revenues fall. You lower price, revenues fall. So the kink demand curve is one way to demonstrate why firms don't like to compete upon price in an oligopoly market structure. Another way of showing price and output are more stable is focusing on the marginal revenue curve. If you recall from perfect competition and monopoly, whenever marginal cost changed, that changed the location of MRMC, which changed price and output. Well, let's see what happens here. Let's draw a marginal cost curve here. What if I were to change marginal cost and lower it? Notice how we have this, we're intersecting at the same place. Let me change this to a laser pointer here. And in order to find, let's go back to the first marginal cost curve. Oh, well, in order to determine price and quantity, we find the intersection with marginal cost and marginal revenue, right? And it's right here. And in order to find quantity, you simply go down to determine Q, and to determine price, you go up until you hit the demand curve, and you go over to find price. Well, what if we were to lower costs? We have a new intersection, right? But notice how the intersection is taking place in this gap right here, or this vertical portion of the marginal cost curve. And that leads to the same Q and the same P. Let's lower it again. Again, same Q, same P. So as long as marginal cost shifts within this gap, there is no change in P and there's no change in Q. So that tells you modest changes in costs do not always lead to a change in P and Q for an oligopoly market structure. And this makes sense because think about a airline industry. One of the characteristics of an airline industry in the United States is volatile fuel prices. And that dramatically changes a level of profit when fuel prices change. So let's say the industry sees an increase in costs. The MC curve shifts upward. Well, maybe your first instinct as a CEO of an airline is to raise price. But what if you're the very first firm to raise price in the face of higher costs? Well, if your rivals do not raise price, you could lose a significant amount of market share to your rivals. This is why some firms are willing to absorb losses or reduced profits when costs go up just to protect market share. And this is one of the ways of demonstrating price and output are more stable because modest changes in costs don't always lead to a change in P and Q.